Hello everyone, welcome to my channel. In this video, we are going to discuss exercise 1.3 of chapter 1, real numbers. So the first question is, prove that root 5 is an irrational number. So this solution we are going to solve by a method called contrary method or contradiction. So let us discuss in brief what exactly this contradiction method or else method of contrary. For example, on our earth we have only two fruits, fruit A and fruit B. Just assume that A and B are the only fruits which are available on the earth. Now one of your friends gave you one fruit and you need to prove that it is fruit A. So what we will do is, we will do the process in reverse. That is, I will prove that the fruit which was given by the friend is not B. So if I can able to prove that fruit which is given by my friend is not B, then definitely that is fruit A only, because there exists only two fruits. This kind of method is called as method of contradiction or simply contrary. So here also we need to show that root 5 is irrational. So instead of showing the number is irrational, what I will show is it is not a rational number. If it is not a rational number, then definitely it is an irrational number only. So this is what exactly method of contradiction or contrary method means. Okay, now let us jump into the solution then. Prove that root 5 is an irrational number. This process or this method is applicable for all the individual numbers. For example, root 5 or root 3 or root 7 or 2 root 5 or these kind of solutions like this. So first we need to write some sentences compulsory before starting the solution itself. So on the contrary, let us assume root 5 is rational. Okay, first we will assume that root 5 is a rational number, and at the end of the solution I will declare or I will confirm that it is not at all a rational number. So if we can able to prove that it is not at all a rational number, then definitely it is going to be an irrational number only. So on the contrary, let us assume root 5 is rational. So root 5 equals to, here I am saying that root 5 is a rational number, right? So according to the rational number definition, the numbers which are in the form of P by Q. So root 5 equals to P by Q. And here some of the textbooks are following as A by B also instead of P by Q. If you are writing it as A by B or else P by Q, both are same only. So, and the condition we need to write, right? That is, both numerator and denominator, those are P comma Q belongs to integers and Q not equals to 0. Prove that root 5 is irrational. So first we will think that it is a rational number, and after solving the solution we will get to know that it is not at all a rational number. So if it is not a rational number, then definitely it is going to be an irrational only. So we are assuming, right, it is as a rational number. So root 5 equals to P by Q. And the condition compulsory, P comma Q belongs to integers and Q not equals to 0. And one more condition also you need to write, that is P comma Q are co-primes. Co-primes are nothing but, for the number P and for the number Q, there won't be any common factors except 1. For example, if I take number 2 and number 3, for 2 and 3 only 1 is the common factor. Otherwise, if I take 3 and 7, for 3 and 7 only 1 is the common factor. And next, if I take for example 5 and 14, for the number 5 and 14 only number 1 is the common factor. So these kind of numbers are all called as co-primes. 5, 14 are co-primes, 2, 3 are co-primes, 3, 7 are co-primes. no common factor except 1. Okay, now here left side we have root 5, right? So root 5 we cannot able to simplify further because it's an irrational number. So to proceed further, what we will do is we will do squaring on both the sides. Squaring on both the sides. So what it will become then? Root 5 whole square equals to p by q whole square. If you are following with the a by b means just in the place of p by q you need to substitute a by b as it is the process continues. So here square root and square will get cancelled, then we remains with 5 equals to p by q whole square. Left side part as usual 5 equals to, now this square is applicable for the numerator as well as for denominator, right? So let us separate that now. So what it will become? P square divided by q square, then taking the denominator to the left side, so it will become 5q square equals to p square. Now take 5 to the right side, so we will get q square equals to p square by 5. Here it is multiplication, if we take another side it becomes division. Now how we can read this p square by 5 as? So p square by 5 can be read as 5 divides p square, otherwise denominator divides the numerator. That is the meaning of this exactly. So 5 divides p square. If 5 divides p square, then 5 divides p also. It's actually a theorem. If 5 divides p square, then 5 divides p also, whatever it may be the number. If 3 divides p square, 3 divides p also. If 7 divides p square, 7 divides p also. Compulsory that is. Take any number and you check if you have doubt means. So just 5 divides p square, so 5 divides p also. Now 5 is dividing p, right? Then this can be expressed as a mathematical expression like p divided by 5, which is dividing, that should be in the denominator. So p by 5 equals to, now I said that 5 divides p. So if 5 divides p, then definitely it gives some answer, right? So that answer we are taking as some constant c. Now take this 5 to the right side, so we will get p equals to 5. If it go that side, it will become multiplication 5c. Now observe this one. Here we got one equation, 5q square equals to p square, right? 5q square equals to p square. Here p value I got as 5c, right? So this p value I am going to substitute in the place of p. 5q square as it is, p value is 5c, right? So 5c whole square. 5q square equals to 5 square 25, c square as it is. Now taking 5 to the right side, so we will get q square equals to 25 divided by 5, c square as usual. 5 ones are 5 5s are, so we will get q square equals to 5c square. Taking 5 to the left side, q square divided by 5 equals to c square. Now if we observe this left side part again, q square divided by 5, that can be read as 5 divides q square. 5 divides q square. So if 5 divides q square, then obviously 5 divides q also. So now coming to the previous one, here we say that 5 divides p, and here we got it as 5 divides q. So both sentences together I am writing 5 divides p and q. So now if we say that 5 divides both p and q, then we can say that 5 is a factor for both p as well as q. But according to the condition which we took here, p comma q both are co-primes, right? Here, oh sorry, I may have updated it. P comma q are co-primes. So p comma q are co-primes, right? So it means p and q both does not have any common factor except 1. But here we got that 5 is a common factor for both again. So we got this kind of a contradiction. So we need to write it as this contradiction has arisen due to our wrong assumption. You need to write here 5 divides P and Q, right? It contradicts the fact that P comma Q are co-primes. So this contradiction has arisen due to our wrong assumption. So the given question root 5 is irrational number. Moving to the question number 2. Prove that 3 plus 2 root 5 is an irrational number. The first statements as usual. On the contrary, let us assume 3 plus 2 root 5 is rational. So 3 plus 2 root 5 equals to A by B or else P by Q. The conditions are P comma Q belongs to integers, Q not equals to 0, and P comma Q are co-primes. Of course, in this kind of questions, again P comma Q are co-primes, that topic is not necessary, so that's why I'm not going to include. If you want, you can do that one, no problem. Okay, now take 3 to the right side. So we will get 2 root 5 equals to P by Q plus 3 becomes minus 3. This 3 I am writing it as 3 by 1. So 2 root 5 equals to P by Q minus 3 by 1. Left side 2 root 5 as it is equals to P into 1P minus 3 into Q 3Q divided by Q into 1Q. Taking 2 to the right side, root 5 equals to P minus 3Q divided by 2Q. Now, in the beginning we took one condition, that is P comma Q both belongs to integers, right? So now if we observe this right side part, in the right side part we have P, alphabet Q as well as 2 and 3. So as 2 comma 3 comma P comma Q are integers, RHS is rational. So here in the place of P and Q, whatever the number you want, you substitute from the integers completely. Always this right side part will get a rational number only. And already in the condition only we took that Q is not equal to 0, the denominator should not be equal to 0. So next, coming to this LHS part, root 5. Root 5 is an irrational number. So as 2, 3, PQ are integers, RHS is rational, but LHS is irrational. So here we are saying that right side part is a rational number and left side part is irrational number. Rational equal to irrational, which is completely senseless comment. So we got this kind of wrong answer because of our wrong assumption. This contradiction has arisen due to our wrong assumption. So the given question is an irrational number. Moving to the next one, third bit. Prove that the following are irrational numbers. So let us take one by one number and let us try to prove this one. The first question is given as 1 divided by root 2. It's very easy. Let us take the first one only and we will solve that one. Then after we'll move to the next one, then after another one, then after another one. They still okay. 1 by root 2. So first, as usual, on the contrary, let us assume one divided by root 2 is rational. So 1 by root 2 equals to A by B. Okay, if why I am saying again A by B means in some of the textbooks maybe you will be having P by Q, and in some of the textbooks you will be having A by B. So that's the reason I covered already P by Q. So that's why I am going with this A by B now. where a comma b belongs to integers, b not equals to 0, a comma b are co-primes. Now what we need to do is just do reciprocal. Complete equation, that is left side part and right side part, we need to do reciprocal. 1 by root 2 reciprocal is root 2 by 1. A by b reciprocal is b by a. Now left side we have root 2 by 1, right? So root 2 by 1 is nothing but just simply root 2. Root 2 equals to b by a. Now look at the right side part, we have b by a, right? So nothing but a alphabet and b alphabet, right? So as a comma b are integers, RHS is rational, but LHS is irrational. Same as usual again, this contradiction has arisen due to our wrong assumption. So 1 by root 2 is an irrational numbers. Next, second question in this, 7 into root 5 or simply 7 root 5. First statements as usual, on the contrary. Let us assume seven root 5 is rational. So 7 root 5 equals to p by q, where p comma q belongs to integers, q not equals to 0. Take 7 to the right side. Here it is multiplication. If we take another side, it becomes a division. So we will get root 5 equals to p by 7q. Now as or else since you can write, since p comma q are integers, RHS is rational, LHS is irrational. This contradiction has arisen due to our wrong assumption. So 7 root 5 is an irrational number. Next, in this third bit, last question, 6 plus root 2. First statements as usual, on the contrary, let us assume six plus root 2 is rational. 6 plus root 2 equals to a by b, where a comma b belongs to integers, b not equals to 0. Take plus 6 to the right side, then it becomes minus 6. So we will get root 2 equals to a by b minus 6. This 6 I am writing it as 6 by 1. So left side root 2 equals to a into 1a minus b into 6b by b into 1b. Now right side if you observe a, b and 6. Since a comma b comma 6 are integers, RHS is rational, but it contradicts the fact that root 2 is irrational. Just try to observe the previous sentence and this sentence. In the previous sentence, I wrote that since a comma b are integers, RHS is rational, but LHS is irrational. But in this, I am trying to write a different sentence. Since a comma b are integers, RHS is rational, but it contradicts the fact that root 2 is irrational. So this contradiction has arisen due to our wrong assumption. The previous sentence or else this sentence, both are same and both are 200% correct only. So don't get confused. If you like my video, please don't forget to share with your friends. Thank you.